Mercury has been found in Egyptian tombs dating back to 1500 BC. In about 350 BC, the Greek philosopher and scientist Aristotle described how cinnabar was heated to extract mercury for religious ceremonies. Demand for mercury greatly increased in 1557 with the development of a process that used mercury to extract silver from its ore. Much of the impetus to develop mercury ore deposits in the United States came after the discovery of gold and silver in California and other western states in the 18th century. The process for extracting mercury from its ore hasn't changed much since Aristotle first described it over 2300 years ago. Mercury ore is crushed and heated to release the mercury as vapor. The mercury vapor is then cooled, condensed, and collected. Mercury ores are formed naturally when warm mineral solutions rise towards Earth's surface under the influence of volcanic action. The most common ore is red mercury sulfide, also known as cinnabar. The ore is brought out of the mine using power tools and with the help of explosives. It is then broken into smaller pieces with the help of cone crushers. The crushed ore is then ground even smaller by series of mills. Once the ore is finely powdered, it is then fed into a furnace or kiln to be heated. The heated cinnabar reacts with oxygen in the air to produce sulfur dioxide, allowing the mercury to rise as vapor. This process is called roasting. The mercury vapor rises through the exhaust along with sulfur dioxide and water vapor. The mixture of gases passes through a water-cooled condenser. Mercury, which has a boiling point of 357 degrees Celsius, is the first to condense into liquid, leaving the other gases to be vented out. The impurities are removed by filtration, leaving a mercury that is about 99.9% pure and can be used directly from roasting and condensing process. Higher purity can be obtained through several refining methods. The most common refining method is triple distillation, in which distillation process is performed 3 times, with the purity increasing each time. The ultra-pure mercury commands a premium price. Mercury, being the only liquid metal, possesses many unique characteristics like good electrical conductivity, very high specific gravity, and high surface tension, and also a very high coefficient of thermal expansion. All this makes mercury an excellent material for many purposes. It finds application in gold and silver extraction, in electrical and electronic switches, in thermometers, in fluorescent lamps, and in dental amalgam fillings. But unfortunately, it is highly toxic to humans, due to which its use has severely declined over past 30 years. Short-term exposure to mercury vapor can produce weakness, chills, and vomiting, while long-term exposure have serious consequences. It can result in insomnia, excessive salivation, and other debilitating effects. Mining and processing mercury ore can expose workers to mercury vapor as well as direct contact with the skin. Mercury has also been known to have harmful effects on fish, birds, and mammals. Its use and release to the environment has come under increasingly tight restrictions. Its mining has been stopped in Spain, which used to be the largest producer of mercury in 1989. Mercury is still an important component in many products and processes. Improved handling and recycling is expected from industries as well as users.